We're going to go through the Chapter 3 review with me working out the problems and explaining how I get my answers. We start off here. This whole review is just a bunch of equations that we're solving. So we're going to start off here with some easy ones. These first four, in fact, you might be able to do pretty easily in your head. I'm going to go ahead and show the work that we do to get those, but let's go ahead and start with number 1. So we have v minus 19 equals negative 39. What I want to do is say, since I'm doing v minus 19, the opposite of that means add 19. So I'm going to write that underneath the 19, and then I'm also going to write it on the other side of the equal sign underneath the number that I have, because I can add numbers with other numbers. Doing negative 19 right here and adding 19 to it gives me 0, so those cancel out, leaving me with v on the left. And then I do negative 39 plus 19 on the right. A negative and a positive we would subtract to get our answers. 39 minus 19 is 20, but it's a negative 20 because my bigger number was negative. So our answer here is negative 20. You can check when you solve an equation to see if you're right by taking the answer you got and putting it right here where this letter was to start. So if negative 20 is the right answer, I should be able to do negative 20 minus 19, and that should equal negative 39. It does, because the two negatives, when you add them together, give you something more negative collectively. So 20 plus 19 is 39, but it's negative because they were both negative to start. So on number 2, we have k divided by 8 equals 5. It might be easier just for us to think about what number divided by 8 equals 5. The math that you do to solve this is to multiply both sides, because multiplication is the opposite of the division that's happening. Multiplying by, it's really like we're multiplying by 8 over 1, cancels out those 8s so that we get k equals 40. And that's our answer. And if you think about it, 40 divided by 8, does that really equal 5? Yes, it does. So we did it right. We've got negative 14n equals 84. I'm going to divide both sides by negative 14 because the operation happening here is multiplication. So I'm going to do the opposite and divide. When I divide, I have to make sure to also divide by that negative. Otherwise, I won't have gotten rid of the negative that's in front of n, and I'd have to leave it there and do a whole extra step. So I divide both sides by negative 14. Now, I may not know what 84 divided by negative 14 is off the top of my head. Actually, I don't. But a positive divided by a negative gives me a negative. And I can try simplifying this if I don't know if it goes in evenly. So I can try dividing them both by 2 since they're even. And that gives me 42 and 7 and still negative. And then hopefully I can say, okay, I do know that 42 divided by 7 is 6. So my answer is that n equals negative 6. And again, we can check our answer by going back and plugging in. This is a pretty easy one. Again, we could be just thinking about this. What number plus 14 equals 30? But the work to show to get it is that what we're doing is subtracting 14. Subtracting 14 from both sides. 14 minus 14 cancels out. That's why I'm subtracting it instead of adding it, because I want it to cancel out. So 30 minus 14 is 16, and that equals m. So that is my answer. Now we want to go on to some harder problems. So I'll move this up some. This is going to take more steps than the first 4. On number 5, there's actually 2 ways we can go about this, because we can do the distributive property, and that's probably what most people would think to do first. If I do that, I get negative 90 equals negative 45 plus 5n. And then I'm going to take that and use my equation rules. So my equation rules, whenever it's not just one step like it was on 1 through 4, is I always want to do what's not connected to n first. So the 5 and the n are like super close together, like buddies, because multiplication right there is super strong. What I want to do first is move the negative 45 because it's farther away from n. It's also, another way to think of it is it's the opposite of what our normal order of operations are. Normally, order of operations, we save addition and subtraction until last. But when we're solving an equation, we're trying to undo operations, and so we work backwards, and we start with the addition and the subtraction. So I'm going to add 45 to both sides. And sometimes these numbers are tricky, like negative 90 plus 45. You want to subtract them because they're not the same sign. And when I subtract, it might be easier to actually switch it around and say I'm doing 90 minus 45. So I have to borrow from the 9. 10 minus 5 is 5. 8 minus 4 is 4. And then say, okay, it's 45, but it's negative because the bigger number was negative. Negative 45 equals 5n. I'm going to divide both sides by 5. And get negative 9 equals n. The other way to do it, and I'll just write it out real quick and show you the other way. The other way is to, instead of distributing, say I have 5 times this parentheses, and so what I can do is I can divide both sides by 5. And when I do, I have to do negative 90 divided by 5, which is negative 5 goes into 9 once with 4 left over. 5 goes into 48 times. Then I don't need my parentheses anymore. I can just write negative 9 plus n. So then I'd add 9 to both sides and get negative 9. So it's whichever way you want to do that. You might think it's easier just to distribute. If you realize that you can divide, and if it divides evenly, that actually is one of the, to me, that's an easier way to do it personally, but it's up to you. So whatever you feel more comfortable with. Number 6. So we want to start by moving the negative 8. So we're going to add it. The way I decide whether or not I'm adding or subtracting my number is this sign right here that's in front of it. It doesn't have to do with anything else in the equation. It's a minus 8, so I'm going to add 8 to both sides because that's what's going to make that equal 0. Negative 8 plus 8 is 0. So I drop down my 6k. 12 plus 8 is 20. And then our final step in most equations is going to be this step where I divide by what is in front of k. So that gives me k equals, well, 20 does not divide evenly, and so I'm going to try to reduce my fraction. They're both even, so I can divide them both by 2. So that's 10 over 3. That would be a good answer. You also could write our answer as 3 1/3. If you wanted to change it to a mixed number by saying 3 goes into 10 3 times with 1 left over. Or you could divide it out to get a decimal and you get 3.3 repeating. I personally, as a math teacher, would rather you just write 10/3. What I don't think any math teacher ever wants is for you to leave it as 26ths because that is not the simplest fraction you can get. We always want to simplify our fractions, but we don't always necessarily have to change it to a mixed number. There's a difference between those. So we want to simplify to 10/3. If you go the extra step to get the mixed number or the decimal, fine, but not necessary. Let's turn the page. All right. This one at the top left, negative 1 minus x equals negative 4. I'm trying to get the negative x by itself, and there's not a number in front of x right now, but if we think about it, we can hopefully remember that there should be a 1 in front of x whenever nothing is written in front of it, because that means we have 1x. I'm going to move this negative 1 at the beginning. It's a -1, so I'm going to add 1, and that's because of this negative sign right here that I choose to add 1. That gives me negative 1x, or if you didn't write down the 1, you just have negative x, equals negative 4 plus 1. They're different signs, so I subtract and get 3, and then I keep the negative from the 4 because it's bigger. And the last step is to divide by negative 1. It is not okay to have x be negative and to call it good. We have to move that negative. If you didn't write the 1, you would still have to move the negative. And so what I want to do is just move that over to the other side by dividing or multiplying by a negative. So I do that and I get x equals negative 3 divided by negative 1 is positive 3. Negative divided by negative makes a positive, and 3 divided by 1 is 1. Now 8 and 10 are going to throw some people off because we have fractions, and the order here matters. The whole left side here is over 14, so the very first thing I want to do is multiply by 14 so that it won't be a fraction anymore. And it's really that I'm multiplying by 14 over 1. 14 and 14 over 1 are the same thing. And what that does is it lets me cancel out my 14s, and it leaves me with m plus 7. Then I do 1 times 14, which is 14. Now I'm ready to finish solving by subtracting 7. 14 minus 7 is 7, so m equals 7. Number 9, we have some parentheses and a negative outside. Just like on 7 where we had a negative without a number, this also we could put a 1. And what we should do is we should distribute that negative. Negative 1 times negative 8 gives us positive 8. Negative 1 times 3p gives us negative 3p. And it equals 30. Another way to think of it is a negative outside of our parentheses is going to negate what we have inside. The term negate usually means, usually it means we're disagreeing with something, right? But in math it means to do the opposite. So instead of a negative 8, now I have a positive 8. Instead of a positive 3p, I have a negative 3p. Now my steps are to add or subtract 8 first, and then to divide by negative 3. Since 8 is now positive, I'm going to subtract 8 from both sides, and I get negative 3p equals 22. And then I'm going to divide by negative 3, and I get p equals, it's a negative, and I personally would just as soon leave this as 22 over 3 since it doesn't simplify. Your other options are that you could change it to a mixed number, although don't drop your negative, or you could change it to a decimal. Just make sure that you have it fully reduced. If you do change it, make sure you change it correctly. That's another thing that's a pretty big deal. Number 10 has a fraction, but it looks different than 8 did because this time I want to save that fraction till later because the whole left side is not over 4. This negative 7 right here needs to be added over before I multiply to get rid of this 4. So it has to do with what is acting directly on k right now, the 4. Whereas before, this 14 was dividing everything, so it needed to get taken care of first. It's kind of a weird thing, so you just have to practice and make sure that you're remembering to follow those steps. I'm going to add 7 to both sides. So it gives me k over 4 equals negative 12 plus 7, which is negative 5. I'm going to multiply by 4 on both sides to get rid of my 4 on bottom, or it's like a 4 over 1. That's why it cancels. So k equals negative a 20. And remember that you can check any of these answers, like on this one, I could check by saying -7 plus -20 over 4 and work this out. This is -5, -7 plus -5 is -12, which is what we were hoping to get. So it looks like I am correct. On 11 through 14, we've got variables on both sides. So what that's going to do is make it so that I want to, as a first step, get my x's together. So on 11, I have an x here and an x here. I either want to add the 4x over or subtract the x over. I don't want to do both. That doesn't make any sense mathematically. I just want to choose one of those things to do. So some people just always move their x's to the left, just for simplicity's sake of always doing the same thing. Some people instead will try to add so that you don't get a negative, which would be a fine thing. So if that's what you're doing, you'd want to add the 4x over because it makes a positive 5x. I'm going to just move to the left for a consistency sort of reason. So I'm going to take the 1x here and subtract it over to the left side. -4x plus -1x, those are two negatives adding together to make something more negative. Make sure you still put the -7 and the equals and the +8, always making sure that you don't drop any negatives along the way. Now it looks just like an earlier problem, like from the front page perhaps. So I want to add the 7 and then I will divide by -5. So add 7, -5x equals 15. I'm going to divide by -5. So x equals, a positive divided by a negative is a negative. 15 divided by 5 is 3. So it's -3. So this next one looks similar. I'm going to get my p's together. So I'm going to add 4p to both sides. And as I'm doing that, I should notice something weird happens here, that actually both sides cancel. If I write what's left over, I have 8 equals 1. And so at this point, I should ask myself, does 8 equal 1? It in fact does not, and so that means that there is no solution to this equation. There would be another situation that could happen, is that I could get something like 8 equals 8 or 1 equals 1. That means that all numbers work for the equation, but since these aren't equal and my variable went away, that's the first thing. Your variable has to cancel out. Then you check. If it's not true, it's no solution. Or you can make this symbol here for the empty set, which also would signify no solution. 13, we've got some distributing to do. Technically, we could divide by -7 here like we tried on the first page. I would caution you about that. If we do divide by -7, we'd divide both of these by -7. So that's why I'm cautioning you against that. I think it might be easier just to distribute this -7 and get -28k minus 28. When you distribute, make sure you multiply both things and that you take into account the negative and things like that. Now let's get our k's together. So I'm going to add 28k to both sides. And that gives me 21k plus 35 equals -28. I'm going to subtract 35 and get 21k equals, well, let's see, that looks like -63. They're two negatives, so they add together and make something more negative. And then I'm going to divide by 21. And if you were having trouble dividing that, remember that we can always try reducing. We can say, well, I know 63 is divisible by 7, and I know 21 is divisible by 7. So we could try that, and we'd get 9 over 3 negative. And then we could say, oh yeah, negative 9 divided by 3, that's just going to be negative 3. But good chance that you did know 63 divided by 21 divides evenly. But if not, always try reducing if you think they have something in common, like if they're both even, or if you could always try to divide them both by 3. You know things are divisible by 3 if you add their digits and get a number divisible by 3. 6 plus 3 is 9, which is divisible. 2 plus 1 is 3, which is divisible. So these were both divisible by 3. So we could have done that instead. 14, let's distribute. So I have 4 minus 6n. Outside of my parentheses, I still have plus 8. One of our first steps needs to be, especially if there's more than 2 things on a side, like there is right now on the left side, there's 3 things. There's most likely like terms. In fact, there has to be if these are linear equations, meaning there's not any squares. So there have to be like terms I can put together. I can put 4 and 8 together right now and get 12. This minus sign is attached to the 6, so if I do 4 plus 8, I'm not going to worry about that negative sign. I'm going to keep it with the 6n, so that 4 plus 8 gives me 12, and I still have minus 6n. Now take a look at what we have right here. 12 minus 6n equals negative 6n plus 12. Those are the same thing. And if I add 6n to both sides, it'll become very obvious, hopefully, that those are the same thing. Because now I've canceled out my variable, and I have 12 equals 12. So earlier on 12, where we were talking about what happens when our variable cancels, I said if what you get is true, then that means any answer will work. So we say that our solution is all real numbers. There's a fancy symbol for that as well. It's an R with an extra line through it. So the difference between 12 and 14 is in both cases our variable went away. Whenever we tried to move the variable, it actually canceled out on both sides. The difference is we got something not true and it made it no solution. So not no. And then here we got something that was true, which meant that anything could be an answer. Now what we have after this is just, we've got some decimals that we're going to work with, which is going to be kind of tedious, I would say. It's not that it's hard necessarily to do this with decimals, it just takes longer. And then after this we've got some literal equations that have more variables instead of having numbers, and some solving for y. So it says to use long division to write our answer as a decimal. So normally we might be able to just write it as a fraction, but here we're going to go all the way to the decimal approximation. We want to round to the nearest hundredth if possible. So if when we're dividing, if it would just keep going, we can stop at the 3rd decimal place so that we can round to the 100th place, which is the 2nd decimal place. There's a trick you can use to get rid of decimals that I can use on 16, where I can multiply everything by 10, and that will get rid of all my decimals. And I bring this up for 16, because if you were thinking about doing that for 15, it doesn't work quite so well when we have a fraction. So if I try to times all of these by 10, it doesn't move the decimal on the bottom to the right like we want it to. It actually would move it to the left. So let's just not move the decimal on 15 and see how we do. I want to subtract the number not attached to x, so I want to subtract the 1.6. It's the same process as what we've been doing, just now there are decimals, so it makes it seem different. I'm going to do 3.8 minus 1.6, which is 2.2. Then I'm going to times both sides by the bottom number, so times by 4.7, so that I get x equals, I personally would go out to the side or below and actually multiply this out. 7 times 2 is 14, 7 times 2 is 14, but I carried, so that's 154. put your 0. 4 times 2 is 8. 4 times 2 is 8. And then add and carry, and I get 1034. Now I've got 2 decimal places here, so my decimal goes 2 decimal places over. So my answer is that x equals 10.34. So on 16, I already talked about multiplying by 10. The reason I'd multiply by 10 is it moves each decimal over 1 place, which gets rid of my decimals. On 17, if I choose to do that, I have to move them all twice, so it's like I'm multiplying by 100. But that'll be here in a second. I want to start by subtracting 94. So it's the same process we've been doing, just because we got rid of the decimals, we've got big numbers. So I'm going to kind of, cheating is not really the right word. I'm going to save us some time in the video. You're welcome to pause the video and work this out and check to see how your math is. But I'm going to actually not look at my calculator, look at work I've already done without a calculator. So in case you were jealous of my calculator use, I didn't use a calculator, I just already have it worked out. So I get 455 equals 57m. We're going to divide by 57. It asked us not to leave this as a fraction, but to find a decimal. So let's do that. Let's come over here to the side and do some long division. When I do it, I need to be prepared to go 3 decimal places. I might not have to go 3 decimal places, but I won't have to go anymore because I'm going to look at the hundredths place and decide whether to round up or not based on the number 1 to the right. So I need 3 to make that happen. 57 doesn't go into 45, but it will certainly go into 455. It does that 7 times. And so I would go over here and do 57 times 7 and get 399. And actually I tried 8 first and found out that it was too big. So I do 455 minus 399, which is 56. Oh wow, that was so close to going in another time. We drop our 0, and then we say 57 into 560. I bet that's 9 times since we were so close to being able to go in one more time. 57 times 9 is 513. So I'm going to subtract 513, and that gives me 47. I'm going to do my next 0. 57 into 470 gives me, that's 8 times. 57 times 8 is 456. And subtracting gives me 14. Last time, drop my 0. 57 goes into 140 just twice. And I get minus 114, which gives me 26. I'm not going to keep going. I'm just going to say, what does that 2 tell me about the 8? Should I go up or down? A 2 tells me that I should stay down because 2 is not close enough to make me round up to the next number. The rule is that 5 and over makes you go up. 4 and lower makes you stay whatever the number is. So this is going to be m equals 7.98. Whew. 17. We're going to times everything by 100. You don't have to do that. If you would rather just deal with the decimals, that's totally fine. Eventually you will have to. Like over here, if I hadn't messed with the decimals, if I hadn't moved them in the beginning, I would have had 45.5 equals 5.7m. When you go to divide with these decimals, you end up moving them. I move the outside decimal, so it's not a decimal anymore, and I move the inside the same amount. So that's how we still end up doing the same division. But you have to make sure to move the decimal the same number of places inside and outside. If I times all of these by 100, it should just get rid of my decimals for me. So let's see. Make sure that you're careful and you don't accidentally just write a number wrong, because that is not helpful. Okay, I'm going to add the 809x over to the left side. So 1064. And I add this together and get 1270x. And then I'm going to subtract 1064. So 1270x equals 562 minus 1064. It would be helpful to come out over to the side and subtract those. And our answer will be negative because of the 1064 being negative. So I get negative 502. I'm going to divide both sides by 1270. So x equals negative something. Let's see. I'm kind of getting into this zone over here, so I gotta watch out. Okay, 1270 goes into 5020. So I'm starting over here. It does that 3 times because 1270 times 3 is 3810. And so I'm pretty sure I tried 4 first and it didn't work. And so if you were thinking the same thing, and we are on the same page. So I get 1210. Now I'm going to drop my next 0, and I'm going to say, how many times does 1270 go into 12,100, which is 9. 9, so 1270 times 9 is 11,430. So we're going to subtract 11,430. And we get 670. And I drop my 0, and into 6,700 is 5 times. And I get 6,350. So 5. 6350, and the reason I'm going ahead and subtracting is to make sure I didn't pick something that was wrong, because if I got something bigger than 1270 there, I would know that I should have gone up a number. So to round here, I'm trying to decide, should the 9 go up or should it stay a 9? 5 makes it go up. Just remember, an 89.5 for your grade, you'd want to get rounded up to an A. So having this 5 rounds up. Since it's rounding up a 9, it actually makes it 0.40. And don't forget that negative. That's a big deal. You wouldn't want to do all that work and then lose points because you forgot the negative. That would happen. That happens to the best of us, but we want to avoid it if possible. Now, these last two are going to give us decimal answers, even though they don't have decimals in the problem. So I'm going to add 9m. And get 6m minus 12 equals negative 2. I'm going to add 12. Get 6m equals 10. I'm going to divide by 6. I can simplify this and then divide, but I do have to divide at some point because it asked me to use long division to write my answer as a decimal. So I can come out over here to the side and do 6 into 10. Or you actually might know this one, especially if you simplify this to 5 over 3. You might be able to figure this out without long division because 3 goes into 5 once with 2 left over. So this is 1 2/3, which you might know as being 1.6 repeating. If I do that, if I say it's 1.666, I'm going to round based on the next digit, so I would say that m equals 1.67. Now, let's see. Be careful here because those are like terms I can add together. And if I tried to subtract 7x from both sides, I might have done that incorrectly, because if I subtract 7x up here, I might be confused about where to subtract it over here. All three of those would add together, basically. You wouldn't subtract 7x 2 different times. What we should get is negative 16x equals negative 100. A negative divided by a negative is positive. And then again, I could go ahead and try to reduce this to 25 over 4 and then divide, or find the mixed number and see if I know what it is as a decimal, or I can just old-fashionedly do good old reliable long division. Back in my day, we did long division till the sun didn't shine. 4 into 25 minus 20, 0. Oh, I can't keep going. So 5 would not change. It would just be x equals 6.25. We are almost done. Almost done. Okay, so we want to solve these 4 equations for the indicated variable. So here they are indicating I want to solve this for x. All I have are letters. I don't have any numbers. So it says g equals x plus c. I need to move the plus c. And I'm going to do that the same way I would do it if it was a number. I'm going to subtract c from both sides. Now when I subtract c, g and c don't actually subtract. It'd be like having grapes and cantaloupes. If I do grapes minus cantaloupes, I'd still have grapes and cantaloupes. It doesn't make any sense to subtract them. So my answer is that x equals g minus c. Okay, on 21 I'm going to solve for x, which means I need to multiply by what's on the bottom. Just like if this was x over 4, we'd multiply both sides by 4. It's x over c, so I'm going to multiply both sides by c, giving me c times g equals x as my answer. Here I'm going to solve for a. A is right here with a k being added to it, so I'm going to subtract that k. Now I'm just going to put it over on the right side. They don't actually combine in any way. If I do minus k, I don't put them right next to each other. I have to leave the minus sign in there. We could do this in a couple different orders. As long as the minus sign is in front of k, and there's plus signs in front of w and v, you can actually rearrange that into whatever order you want to. I'm going to solve this last one for x. Pretend like these are numbers if it's helpful. That, I'd have 10 equals 2 plus x times 3. Just don't change what you're solving for to a number. Well, how would I solve that? I'd subtract the 2 and I'd divide by the 3. So we're going to do that with the y. And then we're going to divide by the m. And we can either write it as z minus y over m, or we could say z over m minus y over m. The m has to go on the bottom of both of them, so either just as one fraction or as 2 fractions, but it does need to go on the bottom of both. Last thing is solving for y. And this is going to come into play next chapter, so we're going to go ahead and practice because it is related to what we just did, where we're solving for a variable when we have another variable. What we want to do to solve for y is add or subtract the x that's on the same side as it, and then divide by what's in front of y. So I'm not going to try to separate the 8 and the x. They're together. I don't need them to be separated because I'm not trying to solve for x. I'm trying to solve for y. So I do that by subtracting the 8x. It doesn't actually subtract, and it definitely isn't a division thing. We're subtracting 8x, so these just go next to each other. Negative 8x minus 24, or negative 24 minus 8x. Whichever of those two that you want to write it as. There's no division happening, we just had to subtract it over. On 25, this x we're going to add or subtract. I subtract it because it's positive. And in fact, on this whole page, they're positive x's, so they need to get subtracted. It leaves me with 5y equals negative x plus 15. Now this time y is not by itself at this point, so I'm going to divide both sides by 5. And when I do that, it divides everything by 5. So I can write one line over 5 like we did up here with m, but it's going to cause us less error if we just put a line under each thing individually, because here it cancels, here it doesn't, and I would think of this like it's negative 1 over 5x. Here I can actually figure out what that is. But what we don't want to do is write it this way and then say that's negative x plus 3, because this also has to get divided by 5. That's just how it works. We have to get used to that in math. Now, I could write that the other way. I could have 3 minus 1/5 x. That's fine too. Finally, 2 more problems. I'm going to subtract the 12x from both sides. Negative 5y equals negative 12x minus 66. I'm going to divide both sides by negative 5. Whoops, I just did what I said I didn't want to do. Divide them both by negative 5. Now, I can't actually divide either of these numbers by negative 5, but I can take into account the negatives happening. A negative and a negative make a positive 12/5 x. Negative and negative make a positive 66/5. So I can write my answer as positives instead of negatives. That's one of the reasons why we're writing it separately, is so that we can check these individually and see what happens. 27, I'm going to subtract 3x from both sides, so that I get negative y equals 1 minus 3x. Y is not by itself right now. It has a negative 1 in front that I need to divide. And when I did it again, like, I need to make these separate lines, because I want you to make them separate lines. Dividing by negative 1, I need to say 1 divided by negative 1 is negative 1. Negative 3x divided by negative 1 changes it to positive. So I can have that as my answer, or I can switch it around. And that's my answer. It may be easier at this point with solving for y like this to just memorize the steps. You add or subtract the x over to the other side. These were all positive, so if this had been like negative 3x, we would add it over to the other side instead of subtracting. So we add or subtract the x, then we check to see if something's in front of y, and we divide by what's in front of y every single time. This has been a review of Chapter 3 of the textbook that I use in my Algebra 1 class, and it's all about linear equations. So I hope you found some useful hints and tricks for solving for x or y or whatever you have to solve for in your life. Thanks.